This is Mrs. O'Neill for AP Chemistry, Chapter 10, Section 5, Further Applications of that Ideal Gas Equation. Your objective is to use this ideal gas equation in calculations, but now we're going to be dealing with density and molar mass of gases. So pause, fill in the blanks, and then play to hear my words. So we're just going to kind of rearrange PV equals nRT to include density and molar mass. So because of the R units, though, I want you to be very, very, very made aware of density will be in grams per liter, not grams per milliliter like you're used to. So something to keep in mind, especially when we get to the problems, when you solve for density, it might be grams per milliliter you're looking for, but it's grams per liter you will be solving for because of the R units, the gas constant. So molar mass and pressure increase, density also increases. As temperature increases, density decreases. So think about that information, but it should make sense, okay? So as mass and pressure increase, density increases. If you have more mass, usually you are a little bit more dense. If you have more pressure, that means you have more molecules in that area. So that should make sense. And as temperature increases, the density decreases. Think of that hot air balloon Mr. Anderson talked to you about. So reactions always happen in moles, but if it's not an STP, we're going to use that ideal gas law to calculate those moles of reactants or products, and then the volume of the reactants or products. So again, I suggest take out a separate sheet of paper to work on these gas law problems. Pause the video. Again, do the problems either one at a time or all at once. I will click through the next slides, maybe kind of saying a comment here or there, going through the solutions and answers. Temperature should always be in the Kelvin unit. Think about your R, that 0.0821, and those units that it has to be in. So remember that density would be grams per liter. And again, I'm going to show you the problems basically step by step, and sometimes I give you that game plan. So you can play and pause the video as you go get stuck along the way. Number one, and already I'm giving you a game plan. So here we go. So 3.13 according to sig figs. So here I used density to go from milliliters to grams. So remember, density is a conversion all on its own. So the reason to go to grams is so that we can get to moles, so that we can use it in PV equals nRT. Number two, we're just using that new density formula that you have in your notes now. So 3.30, again, because of sig figs, changing your temperature to Kelvin right away makes it automatically at least 3 sig figs. So here's your comparison information. So remember, I'm changing grams per liter to grams per milliliter, so it's easier to make that comparison. Number three. And sometimes all you need is to see what formula I'm using, and then you can plug and chug, but go back and reread it and make sure you're understanding why I'm using that particular equation. And again, here's that comparison. Number four, remember capital M stands for molar mass. So we find that krypton has a molar mass of 83.8, which is the closest to that 84 that you just calculated. And again, you might have gotten a different answer if you used 0.08206. That is on your reference sheet, I believe. So you might have gotten closer to the 83.8. Number 5, I'm giving you a game plan. and 58.1 according to sig figs. So you see, they get a little bit more complicated. (1.85 grams per liter). Again, notice the units. And sometimes it's not really that it's complicated, it's just that it's tedious. You have to do many different parts before you can even do the main part of the solution, or the main part of the equation. See you in class. I thought this was a cool the end that I found. Pretty cool, huh? I don't know. All right, see you in class, and if you have questions about those problems, me or your fellow classmates hopefully will help you.